Okay, this video starts with the fourth slide from the notes. We, in order to use the quadratic formula to solve an equation, we must have the equation equal to 0. So, class, how do I move this 9 and make it 0?
Subtract it.
Subtract 9, good. So we'll write it negative x squared plus 4x minus 9 equals 0. So if I'm looking at this equation, A would be negative 1. B is 4, and C is negative 9. And we will put that into the quadratic equation. So negative B would be negative 4, plus or minus square root of B squared, that would be 4 squared, minus 4 times A, which is negative 1, times C, which is negative 9, all over 2A, which is 2 times negative 1. If I do the math that is under the radical, I will get the square root of negative 20. And then if I multiply 2 and negative 1, I get negative 2. This essentially will work just like our previous lesson. We are going to birthday cake 20. The only difference is when you have that negative, there's going to be an I in the answer. So if I were to birthday cake 20, divide by 2, you get 10. Divide by 2, you get 5. Divide by 5, I get 1. And so I have a pair of 2's, that's 2 squared. So when I write it, it's basically 2 radical 5, but there's going to be an I in there. You write 2I radical 5. And that's because this was negative. The square root of negative 1 is I, and so that's where it comes out there. And we have negative 2 right there. And then we can divide everything. They don't like having negatives in the bottom, so I would divide everything by negative 2. Negative 4 divided by negative 2 is 2, plus or minus. Since this is plus or minus already, you're still going to get minus or plus or minus. And then this would just be over 1, and you could just say that the answer is 2 plus or minus 2I radical 5. Went a little outside the box there, but it's okay. So you do the exact same thing that you did on the previous lesson. It's just if you get a negative under the radical, which is only sometimes, you'll have an I in your simplified radical, and they put it between the number and the radical like that. Yeah. Recording.
So is all of this just like reiterate, like the next page is all just reiterate?
Well, this gives us a little bit of different information about the discriminant. So it's just a little fill in the blank, and this will go pretty quickly. On the next page, they give us the quadratic formula again, and remind us it's used to find the roots, which is also called zeros of a quadratic equation. They show us what that looks like, the ax squared and bx and c. The discriminant is the part that is under the radical. So I'm going to sort of lasso that and write it over here. So the discriminant is the b squared minus 4ac part of the radical. That is the part that determines whether you're going to have i's in your answer or not, and how many answers you're going to have. So it's used to figure out the number of roots or solutions or zeros, whatever you want to call it. So if that number under the radical comes out greater than 0, that's positive, you will have 2 real roots or solutions or zeros, whatever you want to call them. If it comes out equal to 0, if you think about that, that means you'd be adding 0 and then subtracting 0, which is going to give you the exact same answer. So that would be 1 real root. And then if it comes out less than 0, which means it's negative, there's no real roots, but there are 2 imaginary roots.
Do you have any extension cords in here I can borrow?
In the closet, maybe on the bottom, on the right-hand side. They're not really extension cords, they're more like power surge things in the bucket.
Yeah, that'll work.
Okay, so let's go ahead and look at an example of this. We're not going to solve it all the way. But we're going to figure out the number and type of roots that we have. So just determine the number of roots for the quadratic equation below. So we're going to do just the discriminant. So A is 3, B is negative 4, and C is 2. So the discriminant is b squared minus 4ac. So we'll just do negative 4 squared minus 4 times 3 times 2. So if you could type all that in your calculator at once, or you could just do it by hand. This would be 16 minus 24, and you end up with negative 8. On your assignment, they're going to ask you for the discriminant, so I'm going to go ahead and box that. That will be one of the answers that we check on the assignment is the discriminant. And then it's going to ask you the number and type of roots. So if we go back over here, this is less than 0, it's negative, which means that I will have 2 imaginary roots. I can't spell today. Imagery.
I remember this. This was nice because we got to like skip all of the work with all the extra steps.
Right. I mean, if you want to know what those imaginary roots are, then you have to do the full quadratic formula. But this will give you just the number and type of roots. Okay, so let's go down here. It says determine the number of x-intercepts for the quadratic equation below. X-intercepts correlate to real roots. And I'll show you a picture of that here in a second. So A on this one is going to be 1, since we just have x squared. B is negative 8. C is 16. So we'll have negative 8 squared minus 4 times 16. And if you do the math, you end up with 64 minus 64, or you could type all of that into your scientific calculator at once if you want to. And you end up with 0. So my discriminant is 0. And what that means, if we were looking at solutions to an equation, that would mean that there's one real root. In terms of a function where they have a y, that interprets into one x-intercept. So because the equation would have one real root if we set it equal to 0. So what that would look like is you'd have a parabola that only touched the x-axis in one place. So we're going to talk about that just a little bit more, and then we will be done. So there's lots of different ways to use the discriminant. If this were an equation equal to 0, this would be one real root. If it's a function with the y or the f of x, then it's an x-intercept.
So we have to do graphing with it now.
Okay, so how many and what type of roots does each graph have? So you're looking at the x-axis. This one touches the x-axis in one place. So that's one real x-intercept. So that's one real root. Up here, it's above the x-axis. It will never touch it, so that's 0 real roots. Which means, basically, that's like in parentheses. It means you'll have 2 imaginary roots. And then over here, it goes through the x-axis twice, which means you'll have 2 real roots. So on the assignment, it's going to give you a graph, and it's going to say, draw a graph of a quadratic function that has 2 real roots. You can draw it pretty much however you want, as long as it goes through the x-axis twice. You could flip it over, you could move it left or right, it doesn't matter. As long as it has those 2 x-intercepts, that gives you 2 roots.
Sounds like our assignment's going to be